Today I will explain assignment question 1, which is about page replacement algorithm using optimal and LRU, which is the least recently used. But my part is I will explain the optimal. If you look closely, the previous page occurrence of page address stream already produced the entry of the page table shown in table 1, which is the frame number 0 produce 1, and frame number 1 produce 0, and frame number 2 produce 4. So based on the given page table, the initial memory frames contain 104. The page reference string that we will process is 14301 24221. First, I will explain the optimal page replacement algorithm. OPT replaces the page that will not be used. For the longest time in the future. Meaning that we need to see which page is the farthest one. So I start with frames containing 104. Okay. If you see, the first page is 1. So page 1 already in memory, so no page fault. So we just copy the previous one. Page 4 also in the memory, so we just need copy the previous one, 104, this one. But page 3 is not in the memory. So which page that we need to replace it with the 3? So looking ahead, page 4 is used farthest in the future. Look at this. 0 is the nearest, and 1 is like middle near. So because of 4 is the farthest, we need to replace 4 here. After we replace it, we need to mention fault, because after replace the fault page, the page fault is occur. So the next page is 0 already in the memory, so no page fault occur. So it just remain the same. 1 also in the memory, so no page fault occur. But 2 is not in the memory, so which page we need to replace it? If you see 1 at here, but 0 and 3 is not in here, maybe it's the farthest. So we can choose between 0 and 3, which both of them we can replace it. But so I want to choose 0. If you want to replace a 3 also can. So I want to replace 0 with 2. So the page fault is occur. We need to mention F. The page 4 is not in the memory also. So we need to find the page which is the farthest. So the farthest one is 3. So we page 3 with 4. So the page fault is occur. So page 2 is already in the memory, so it remain the same. Page 2 also in the memory, so it remain the same. Page 1 is also in the memory, so it will also remain the same. So the number of page faults is 3 per 0, because 1, 2, and 3. So that's all. Thank you for hearing my explanation. For the next part, it's LRU. My partner will explain about this section. Thank you. Bye.
Hello, my name is Nur Nabila binti Yusni. In this video, I will explain about question 1, which is about page replacement algorithm using optimal and least recently used LRU. The process has 5 pages and the memory has 3 frames. So, based on the given page table, the initial we will process is 1 4 3 0 1 2 4 2 2 1. Okay, so Basically LRU LRU replaces the page that has not been used for the longest time in the past. This algorithm is based on the principle of locality. Okay, I will start for page 1. We got page 1 right here, and this is the frame. So we see the frame. Is there any number 1 in the frame? We do, right? So we do not have to change anything. And then we proceed to page 4. Is there any number 4 right here? Yes. So we do not have to change anything. And then we continue for page 3. Is there have any number 3 right here? We do not have, right? So we need to exchange or execute a number. So how do we execute a number? So we need to use rules. We need to see left side and see the most far number. Okay, as you can see, the most far number is 1, right? But we currently have 0 in this frame, so we assume that 0 is the far number in this page address. So we need to execute the 0 to 3. So we execute 0 and this exchange is to 3. Okay, and then we continue to page 0. Is there any number 0 in this frame? No. So we need to exchange it. We use the same rules, which is we see the left side. Is there any number? We see the far number. So which one is the far number? So it's 1, right? So we execute number 1, and then we exchange to 0, and then we proceed. So it is 4 occurs. Basically, currently we have 2 4 occurs. Okay, I forgot to mention. And then okay, when we continue for page 1, we see the frame. Is there any number 1 in the frame? No, right? So we need to exchange it. We need to execute it. We see the far number, which is 0 3 4. Which part is the far number? It is 4, right? So we execute 4 and we exchange it to 1. Okay, so it is 4 occurs. Okay, currently we have 3 4 occurs. And then we have page 2. Is there any number 2 in the frame? No. So we need to exchange it again. We use the same rules again. See the left side and the most far number, which is 0, which is 1 0 and 3. So 3 is the far number. So we execute 3 and exchange it to 2. So it is 4 occurs. Okay, we replace it to 2. And then we continue for page 4. Is there any number 4 right here? No. So yeah, we use the rules again. See the left side and what is the far number? 2 1 0. So basically 0 is the far number. So we execute 0 and exchange it to 4. Okay, it is 4 occur. Okay, and the page 2, is there any number 2 in the frame? Yes. So we do not have to change it. Okay, and then we continue. Is there any number 2 right here in the frame? Yes. So right here, right? So we do not have to change anything. And then proceed for page 1. Is there any number 1 right here? Yes, right here, right? So we do not have to change anything. So basically this is the latest we got in the frame. And for the output, we have number of page is 5 out of 10. So basically for LRU, we got 5 out of 10 of page of 4. So yeah, basically that's all from me. Thank you.